Yes, good morning, guys. Good afternoon and good evening, based on your time zones and where you are watching from or where you are. Welcome to our today's lesson, where we are talking about the action. We are talking about the buffer solutions, and in this case, we are talking about the basic buffer. Okay, we saw what the basic buffer is. These are buffer solutions whose overall pH is above 7. So the overall pH is above 7. So that's why they are referred to as basic buffers. Now consider a weak base such as ammonia hydroxide or ammonium hydroxide. So if you want, okay, let's say this is ammonium hydroxide, okay, ammonium hydroxide aqueous, which is a weak base that partially dissociates in aqueous solution to give us ammonium ions, okay, ammonium ions plus aqueous, then hydroxyl ions aqueous. Alternatively, you can write this equation as ammonia alternatively, and this is the equation that we shall be using frequently, plus water, okay, it will give us ammonium ions, okay, and then aqueous plus the hydroxyl ions, OH ions, also aqueous. Now, in this salt, you have there excess ammonia. So in this solution, you have there excess ammonia, and it will establish this equilibrium. But also in the same solution, you have there ammonium chloride, and ammonium chloride is a strong electrolyte. Okay, is a strong electrolyte which fully ionizes to give us ammonium ions plus aqueous plus the chloride ions, also aqueous. Now, such a solution, it is going to behave as a buffer solution. Remember, we say that buffer solutions, these are solutions that do resist changes in pH when a little acid or a little base is added into it. Now, because in this solution you have there ammonium ions and enough of them, plus excess aqueous ammonia, excess undissociated ammonia. If, for instance, we add there hydrogen ions, the hydrogen ions will react with the excess ammonia. Okay? The hydrogen ions will react with the excess ammonia that is undissociated to form ammonium ions. Hence, buffered from the solution. And the pH won't change significantly. There won't be that significant change in pH. But because you also have their excess ammonium ions, if you add their hydroxyl ions from just a little base, the little base such as the sodium hydroxide, it will dissociate to give us the hydroxyl ions. And now these OH ions, they are the ones which will react with the ammonium ions, okay, the excess ammonium ions in this solution to give us the undissociated ammonia solution, okay, plus water. And water is a neutral compound which doesn't affect. Water doesn't really affect. So the water won't affect the pH. And so there won't be any significant change in the pH. So that's basically how these basic buffer solutions, how they work. Now, let's talk about the Henderson-Hasselbalch equation and how we can use it to determine the pH of a basic buffer.